Good evening all. Am I audible or able to hear me properly? Is my voice is louder? Anand Shrikar, good evening. Bharat Raj Singh, good evening. Divya Jain, good evening. Tejas, good evening. Mine Alone Gamers, good evening. Kitika, good evening. Venkata Raghavendra, good evening. Dimple Cow, good evening. Electronics with Fun, good evening. Satyapriya, good evening. Am I audible or able to hear me? Yeah, thank you all for your valuable response. Thank you. Okay. Yeah. Good evening, Tejas. Deena Dayalan, good evening. Madhuri, good evening. Okay, so today is our 10th day of this 21 days masterclass on STM32, and today we are going to talk about SSD1306 OLED with STM32 Nucleo using STM32 Cube IDE, right? Okay, so in this session we will learn how to interface this particular OLED module with STM32 Nucleo and programming it using STM32 Cube IDE and as well as HAL libraries. So, and OLED is nothing but organic light emitting diode, okay. So this is actually used frequently in displaying text, bitmap images, shapes and different types of clocks, okay. So actually they offer a good view angles and pixel density in a cost effective manner. At first we will take a look at the 0.96 inch OLED display and its pinout connections with STM32 board, and then let's use STM32 Cube IDE to program our module to display different text on the OLED display, right? So let's get into the topic. Okay, this is how it actually looks like. SSD, the module name is SSD1306 0.96 inch OLED, okay. So I have already told you that this stands for organic light emitting diode. So its name shows that it is a flat light emitting technology that is developed when two organic thin films are connected in series between two electric conductors, okay. So when an electric current is applied to these conductors, then the organic compound is made which emits the bright light. So typically one conductor is the transparent conductor between these two conductors. Therefore, there is no need for any backlights to emit the light, unlike in 16x2 LCD. So therefore, this OLED display has improved image quality, full viewing angle, high brightness, better contrast, and you can tell wide color range and low power consumption, more efficient, so many things, okay. So this is actually reliable as compared to simple LCD display. Okay, so it is mainly used in digital display devices such as computer monitor, mobile phone, handle games, television screen, something like that. Although there are several types of OLED displays available in the market, the one which we will be using is the SSD1306 0.96 inch OLED display, okay. So the main component of all different types of OLED display is an SSD1306 controller, which uses either I2C or SPI protocol. So mine is I2C based OLED, okay. So to communicate with the microcontroller. So the OLED performs faster in SPI communication, but it is popular with I2C communication, okay. So the reason for the popularity is lower number of pins. You just only need 4 pins. So the OLED display can vary in size, can vary in color, can vary in shape, but the primarily programmed in a similar way. Okay. So let us take a look at the OLED display which we will be using in this session. It is called SSD1306 0.96 inch OLED display, which has 128 cross 64 pixels. In LCD we have seen like 16 cross 2 thing, like so here 128 cross 64 pixel and communicates only through I2C protocol with the development board. So it is cheap and it is readily available in the market, okay. So now let's talk about the main thing. Before that I want to share you something which is nothing but our internship thing. So you can convert this masterclass into 1 month internship on STM32. So the actual amount of this 1 month internship is for 1999, but there is a discount amount which is available for you, which is only for 799. So this is the registration link. Use this link to register your 1 month internship. And what you will get in this 1 month internship? You will get 30 days of live session plus 30 days of recorded session, 30 days of presentations for download, 5 project source code for download, 1 month internship certificate, participation certificate, and 90 days of access to the courses, hackathon live sessions, and you can join to the community group, and as well as you can join to the thing. Just a minute. So, and also there is a 3-in-1 bundle course is available for you, which is in the STM32 is the default one, you can't change that, but among these 4 courses you can choose any 2 by your own. And the actual amount of this 3-in-1 bundle course is for 3000 rupees, but there is a discount amount which is available for you, which is only for 1199. So this is the registration link to register for 3-in-1 bundle course. So what you will get in this 3-in-1 bundle course? 90 days of live plus 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to the courses, hackathon live session, you can join to the community group and you will get your assignments and mock test. And the main thing is, while making your payment, don't forget to add the courses that you want in the domain tab. That is the main thing, right? Now let's get back to the topic. Okay, so now let me talk about its pin out. It just needs 4 pin. So there are 4 pins in this display. VCC, I mean power pin, ground pin, clock pin and data pin. So the VCC and ground pins will power the OLED display and will be connected with STM32 power supply pin, as they require a driving voltage of like 3.3 volt to 5 volt. But you can go for 5 volt instead of 3 volt, because some OLED doesn't work properly in 3.3 volt. So it's better you go for 5 volt, right? And the clock and the data pins are necessary for generating the clock signal and in the transmission of data respectively. So both of these pins will be connected with the I2C pins of the STM32 board. Okay. So here I provide the connection picture in this PPT. So you just need to connect the ground to the ground, power to the power, and clock to the pin PB6 and data to the pin PB7. So this is the connection. So now let's move for the project setup. Let me open STM32 Cube IDE. It will take few seconds, just a minute. So let me open a new project, STM32. Okay, so here I am going to search for STM32 F446 RE-T6. Let me go for demo. Okay, so as usual, go for system core, go for RCC, enable this high speed clock as crystal ceramic resonator, and then this is totally based on I2C, right? So go for I2C 1, enable I2C over here, and now go for parameter settings, and here you need to change this standard mode I2C speed as fast mode, okay, and then go to clock configuration, change this to HSC, change this to PLL clock. Instead of 25 I go for 8 megahertz, and here the maximum megahertz is 72. I'm going to hit enter, and let me save this. Okay, do you want to generate code? Yes, in CC perspective. Okay, okay, over here first we need to import libraries. Okay, so in the downloadable part I will provide all those library. So now let me copy that library from my file, and just go to core, go to SRC, right click on it and just paste it. Okay, so you will have fonts.c library, fonts.h library, and ssd1306.c library, ssd1306.h library. So these 4 libraries will be available in the downloadable thing, so you can go and grab it over there, right? So here I am going to add using include. I am going to give standard input output dot h, include string dot h library, include fonts dot h library, include ssd1306.h library. Okay, so these are the libraries we needed. Let me build this and let me check do we have any error or not. Okay, so we don't have any error because we have successfully copy paste all those library section. Okay, so now we can go for, let me scroll down, and inside the main function, after all these initialization, there is a thing called user code begin. So here I am going to write few lines of code. I am going to check if ssd1306 underscore, I am going to initialize this path, and then address of h I2C we have taken 1, right? So inside this I am going to just call that error handler function. Okay, and after this I am going to start with a little delay, just 1 second is enough, and after that I am going to add few lines, ssd1306 underscore, I am going to use the function called fill. Inside I am going to give the color black, so this will make your OLED screen black, and then ssd1306 I am going to use set cursor function. Okay, so inside I am going to pass at 0th row 0th column I want to print something. What I want to print? So how to print that? ssd1306 underscore, I am going to using the thing called write string. So this will print whatever you want. So inside I want to print like hello. Okay, so I am going to give the font size, font underscore 11 cross 18. So you will get all these steps in the library part. So here we are having 4 libraries, right? So just go through all the libraries, then you can understand why we are using all these steps. The library itself we mentioned that black color and all these stuff, font size, everything. Okay, so we can use it here easily. And now I want to print that particular letters in the white color, black background, and I want to print the string in white color. That's why we have used ssd1306 fill function. Inside we need to pass that black, and where I want to print, at which position I want to print. Using set cursors we can set the position, and using write string method we can print whatever the thing we want, and we need to mention the font size and its color. Okay, and after that ssd1306 underscore, I'm just going to update the screen. Okay, so inside we need to pass address of h I2C 1, and then let's end it with a little delay. Just 1 second. Okay, so this is the program. Let me build this and let me check. Okay, now there is no error. And now let me show you the output video. I have already pre-recorded the output video. I will show you, right? Okay. So I have already told you the connection part. Here I am having this. I hope it's visible properly. Let me play this. After uploading your program into your microcontroller, and this is how your output will look like. It will print hello like this. Okay, at 0th column, 0th row, it will print hello. You have given the font size, the background color is black and the letter color is hello. Okay, so this is the output. Okay. So now I am just going to alter this same program. Okay, so what I am going to do is that at the beginning I am going to mention something integer type. Okay, I am going to take the variable n and I am going to initialize this with 0, and then I am going to take an array char. The array name is num. Inside just for t is enough. Okay, so this is the one, and then I am going to the while loop. Here I am going to add a few lines. So the same thing as here. So let me copy this from here. Let me copy this and let me paste it over here. SSD one. May I have this OLED in Proteus? Yes, I think, but you need to. Some Proteus may not have the inbuilt library for all those stuff. So you have to download that particular library from Google, and then you have to upload it in the Proteus software file, and then you can use it, right? Like for STM32 board doesn't previously embedded in the software itself, so you have to download that package and you have to install that package in the software. Like that you can use that. Okay, so whatever the component that are not presented in the Proteus, you have to download the package and you can use that, right? Okay, so here I am going to fill the background with black color. At the 0th column, 0th row, I want to print like numbers. Okay, I just want to let me show you. Okay, yes, printf. Inside I am going to pass the num variable, and then I am going to use like counter, which is equal to %d. Okay, after that I am going to give the variable name n. Okay, so what I want to print? I want to print that number. So counter, which is equal to number. So how to print that? It will only print 0th number. For that, SSD1306 underscore update screen. So you should be in uppercase, and inside you need to pass address of I2C 1, and after this I am going to give a little delay of 1 second, and I am going to increment that n variable. So this will make like counter, which is equal to, it will increment the number. So it will print like 0, 1, 2, 3, 4 continuously, right? So let me build this. Let me check, do we have any error or not? No, we don't have any error. Okay, so here you can see the output. Let me play it and see. First it will print hello, and then it will print like counter, which is equal to 5, 6, 7, 8. It will print the number like this continuously. Okay, so this is the output. Okay, so now let us do one more thing. Let's just play with pixels. Okay, I just want to, just a minute. Now let's print the rectangle box at the corner of the OLED. Okay, so for that I am going to write some piece of code. Okay, see here I am going to use for loop. So inside for loop, integer type n which is equal to 0, n which is less than 128, and n I am going to increment this. So inside this STM32 underscore I am going to use the thing called draw pixel. So inside I am going to pass n comma 0 comma 0 is nothing but the position. Okay, so that's it. Now after the same thing, let me copy this and another for loop. Okay, so inside this thing is same. So here instead of 0 I am going to give like 63. You already know that 128 cross 64 pixel, right? So you have to give the position properly, then it will print the rectangle box at the corner of the OLED thing. So now let me paste it again, and now here we need to change, instead of 128 n less than 64, and here you need to give like 0 comma n and then white. Okay, and let me copy this and again let me paste it. Now we need to give like instead of 0 127, and then after this STM32 update screen. So address of I2C 1, and then let's end it with the delay. Let me check. Okay, there is no error. Now let me show you. Hello, and you can see here, right? So it will draw the rectangle line in the corner of the OLED. So you have to correctly mention the place where you want to do it. So you already know that 128 cross 64 is the pixel. So you can play with the numbers. Okay, so this is how you can use this is how you can print text. This is how you can play with draw pixel, something like that. Okay, so instead of I2C LCD or LCD, you can go for this OLED. It will be helpful to you. Okay, so this is what about today's session. I hope you understand this. So once again let me come with the thing. So you can convert this masterclass into 1 month internship on STM32. So the actual amount of this 1 month internship is for 1,999, but there is a discount amount which is available for you, which is only for 799. So this is the registration link, and you will get 30 days of live plus recorded session, 30 days of presentations for download, 5 project source codes for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live sessions, community group. You can join to the community group. And STM32 is the default course. You can change that. This is the 3-in-1 bundle course. Among these 4 courses, you can choose any 2 by your own. And the actual amount of this bundle course is for 3,000 rupees, but there is a discount amount which is available for you, which is only for 1199. So use this registration link to register. And what you will get in this 3-in-1 bundle course: 90 days of live session plus 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to the courses, hackathon live session. You can join to the community group and you will get your assignments and mock test. So while making your payment, don't forget to add the courses that you want. That is the main thing. So this is all about today's session. I hope you enjoy and understand the session. So let's catch up at tomorrow's session with another topic. Thank you all. Have a very great day.